So when we talk about improbability, things that are mutually exclusive, what do you guys think mutually exclusive might mean, just by the words themselves?
They're both exclusive.
Both exclusive? What's exclusive mean?
By itself.
By itself? Okay, so mutually exclusive pretty much means two things that cannot happen at the same time. They're two individual things that cannot occur at the same time. So like on, what was it, the first one from your assignment yesterday, can you be in both first period math 2 and math 1 at the same time? No. What did your Venn diagram look like? Two separate circles, they didn't cross ever. So mutually exclusive is when events cannot happen at the same time. So our Venn diagrams tend to look like two separate circles that don't ever cross because they can't. If they cross, that means they're not mutually exclusive. Now, when we find the probability of mutually exclusive events, so if I have two events, A or B, and I know that they're mutually exclusive, and I'm asked, what's the probability of this or this happening? What you're going to do is you're going to find the probability of each event and add them together. And that'll be your total probability. Now, if you were asked, what's the probability of A and B happening at the same time, what would you say? So by definition, mutually exclusive means they cannot happen at the same time. And means that they is saying what's the probability they will happen at the same time? 0. Okay.
What if there's a number outside the two circles?
That just affects your total. So it's still part of your probability. Okay. It would just, so when you do your totals, so the only one that was mutually exclusive last night was the very first one, which was, I think our total was 60. So you either had it or you didn't. But if you have something on the outside, so I don't know, I'm trying to give an example of one that might happen. It would just affect your, okay, so if you look at your assignment number 6 to 9, the only thing that affects is the overall probability. So if you look at event A, on that one, your probability would be 12 out of 50? 52? No, 50. Because we're adding that 8 in there. So it's going to show up in the probability. It doesn't affect the mutually exclusive part at all. Okay, so we're going to be working with trying to figure out if events are mutually exclusive and then find probabilities of them. So if it says the probability of A or B, just find each individual probability and add them together. If it says A and B, you're going to say 0 because it means it can't. If it's mutually exclusive, it means it can't happen. Now the other thing, I'm trying to remember if it shows up today or tomorrow. It shows up today. What if I were to say the probability of not A or B? This would be the whatever's outside.
Yeah.
Okay. Sometimes we know what's outside, sometimes we don't. So like in 6 through 9, we know what's outside. We know it's 8. But what if we don't know what it is? What you can do is you take, what do we know we have? Well, actually, let me rephrase this. Something can either happen or it can't. It can't kind of happen. If it kind of happens, we say it happens. In probability, it's very black and white in that sense. It either occurs or it doesn't. So whether it occurs or not, together, the occurring and the not occurring have to be your total of 100%. Because those are your only two options. So if it occurs plus when it doesn't occur would equal 100%. So when we talk about not A or B, we take 1 minus the probability of A or B. So figure out if what A or B is, and then just do 100% minus that. Because together they'd have to be 100%. So even if you look at that 6 through 9, that Venn diagram there, that 8 on the outside, if we were to find the probability, so it was 8 out of 50, that'd be the same as 1 minus 42 out of 50. That would also give us 8 out of 50. They're going to give you the same result, it's just two different ways to think about it.
But if you do probability of A plus probability of B, wouldn't the probability always be 1?
No.
Because you're adding them together.
If we look at that Venn diagram on 6 through 9, and we add 12 and 30, are we getting to 100%? Because you never know what's outside. Here it's showing it to you. Not all the time will it do that. And we're going to do one where it doesn't show you.
So, like on 6 through 9, would it be, when you combine the two, it'd be 12 plus 30, which is 42 out of 50?
Mm-hmm. So like on that one, your probability of A or B, you would do 12 plus 30 out of your total. Yeah, so 42 out of 50. So if we did not A or B, we can do 1 minus 42 out of 50, and we get 8 out of 50. Or you can look at your Venn diagram there and see that what was on the outside for your not, 8 out of 50. It's just the difference is when you know what the outside is already or not. So like on that one in particular, sorry, I have answers, otherwise I'd show you. Like on this one in particular, it told us what that outside number is. On our example, do I tell you what our outside number is? That's where we have to do this 1 minus, because there is no other way to figure it out. So what you're going to be looking at mostly today is trying to determine if events are mutually exclusive and then finding probability. And you want to be really careful when you read these, because the or, the and the not are all 3 different ways to do it. So you have to read your problem carefully. So here we have 2 events, A and B. We're told that they're mutually exclusive, which means we know that these are our 3 ways we can find our probability. It tells us that the probability of A is 0.6, the probability of B is 0.25. So what's our probability of A or B? Higher than that. So or means we're going to add our 2 individual probabilities. So we're going to, so 0.6 plus 0.25, our probability is 0.85. Now, sometimes that symbol right there, it's called the tilde, it means not. So if you see that, I think on today's we write it out, but eventually they're going to start using that symbol. That symbol just means the word not. Yes.
For A, what if they asked you for a specific A or B? Like just A in general, like if it asked for just A, would it still be the same 0.85?
If it asked for the probability of A, I would write 0.6.
Okay, that's it?
Yeah, this is, only time I have to add them is if I have A or B, when it's mutually exclusive. So not A or B, we would take our 100 or our 1 minus the 0.85, and we get 0.15 is the probability we'll get something else. So that would be our number that's outside of our 2 circles. And then what's our probability of A and B? 0.
How does 0 come in the order?
It means it can't happen. So the word and means your intersection.
Okay.
So it's when they can both happen, but because they're mutually exclusive, that can never happen. So now let's draw this in a Venn diagram. So if we have, so in other words, we're going to create our Venn diagram to look something like 6 through 9. So here we have event A, event B. Does anything go in the intersection? No. So what's our probability of event A? Probability of event B? Probability of neither one? So this would be your not A or B. So this is what A is, our 0.6, our B. This would be if it's neither one. So then not A or B. You could also draw this as just two separate circles, A, B. Some people like to turn them into numbers, so they'll turn it into like the percent number, and they'll do 60, 25, and 15. So that way they don't have decimals. I really don't care. I'm okay with the decimals. If you do draw your circles overlapping, make sure there's nothing in the middle because they can't actually intersect. But that's what it would look like in terms of a Venn diagram, which is very similar to how 6 to 9 is set up for you at the beginning. Okay. You'll also see in your homework that we talk about the different ways that you can represent probabilities. Now, we've been doing decimals and fractions mostly, but you can do percents. I'm going to say stick with fractions and decimals, just because percents you end up sometimes having to round, and then if you round wrong, then you're wrong. So it's better just to stick with decimals and fractions. This is all you're doing today, is determining is something mutually exclusive, and then finding the probabilities of it. Any questions on either of those two things? Okay, then go ahead. You guys